crosses over through 0. Look, this is one of the questions from the homework graphs, exercise 5.7. It was to sketch y equals 2 tan 3x. Now, just keep in mind what the normal tan function looks like this, where that's pi on 2 or 90, and that's 3 pi on 2, and in here is pi. That's what the normal tan function looks like. Let's not worry about the 2, the coefficient yet. Let's work out the period. Now the period of the normal function is pi, but the period of y equals 2 tan over 2 tan times 3x, the period of that is pi on the coefficient of x, which is 3. So what I would do, just start drawing it normally again, just as it is. You know, it's still going to be the same shape, guys. But instead of this being pi on 2, you know how this goes from minus pi on 2 to pi on 2, and it takes a period of pi? The new period is pi on 3. So this pi is divided by 2, so pi on 3, this would be pi on 6, minus pi on 6, because the two of them added together. See, you know from there to there, in the original one is pi, yes or no? So notice you went half pi on this side, half pi on that side. So same with this, our new period is pi on 3. What's a half of pi on 3? It's pi on 6. So go to pi on 6 there and pi on 6 there. Because you know that tan of 0 is still going to be 0. So there, so what would this be? This is another... Yeah, let's not worry about the 2 yet. We'll fix that in a minute by just putting a number somewhere. Oh yeah, from 0 to 2 pi, yeah. So what, add another pi on 3 to pi on 6. What's pi on 6 plus another pi on 3? Isn't that pi on 6 plus 2 pi on 6? It's 3 pi on 6, which is pi on 2. And then keep going. Add another... So now another pi on 2 plus another pi on 3, isn't that 5 pi on 6? And you've got a lot of them in there. Add another pi on 3 to that, 5 and 2, 7 pi. See, look, isn't pi on 2, this, look, 1 pi on 6, this is 3 pi on 6, 5 pi on 6, can you see the pattern? Pi on 2 is the same as 3 pi on 6, 5 pi on 6, the next one will be 7 pi on 6, 9 pi on 6. You've got to go all the way to 12 pi on 6, which is 2 pi. Now, you don't need this beginning bit. We wouldn't make you do it all. You have to label the asymptotes. I'd be putting the asymptotes, and the intercepts are halfway in between. But look, if you write that, instead of writing it as pi on 2, I'd write it as 3 pi on 6. It's better, because now you know what this one is. What is it? 2 pi on 6. See, this is 1 pi on 6, 2 pi on 6, 3 pi on 6, 4 pi on 6, 5 pi on 6. So when you get the different denominators like the pi on 2, I'd keep it with the 6. It makes it easier to keep going up. All right, so you've got to keep going all the way to 12 pi on 6, because 12 pi on 6 is 2 pi. All right, now, just 2 times, what's going to give, we know that pi on 4, pi on 12, you know how tan of pi on 4 is 1? How are you going to get pi on 4 now? It's got to be 3 pi on what? On 12. Isn't pi on 12 halfway between 0 and pi on 6? 1/12 is half of 1/6. So the pi on 12 is here. So at this value, it's not going to be 1, it's going to be 2. And that's where you're showing the 2. So always look for where the old tan pi on 4, like we know tan pi on 4 is 1. 2 tan pi on 4 is 2. Are we okay with that? So how are you going to get your pi on 4? Because it's 3x. 3 pi on 12 gives you pi on 4. 2 tan 3 pi on 12. 3 times pi on 12 because the graph is 3 times x, and these are the x values. So it's 3 times pi on 12. That's your x. Okay? And you'd have to keep going. You don't now. What we don't need is this. And you just keep going until, I think the last bit will be one of those. You keep going till 12 pi on 6, which is 2 pi. Yeah. 2 sine x on 2. Isn't the period, what is the coefficient of the x at the moment? So the period is 2 pi divided by a half, which is 4 pi. So instead of it taking, you know how, instead of it you doing a whole period in 2 pi, it takes 4 pi to do it, right? So what you'll do a normal drawing if you want, and then you can rub it off. You know how a normal one looks like that? But now that's going to be 4 pi. And this is 2 pi. So you know what you do? You draw it and you scratch this all off. Makes it easier. Alright, so the normal period's 4 pi, but they only want you to draw it up to 2 pi. So draw the 4 pi in pencil, rub this bit off. Does that make sense? And add a 2 and a minus 2 because the amplitude is no longer 1. So what you do is you'll then scratch this off. I don't need that. That's what they want. Because they only want it from 0. So it's much easier to draw it and rub off what you don't want. If you try and do it the other way, it's too hard. See, when you draw it, you go 4 pi. One period is 4 pi. That's 2 pi. This is pi. We don't need the other bits.
And then 4 cos x on 4, same thing.
Yes. Well, 4 cos x on 4, the period is 2 pi on a quarter, which is 8 pi. So you would draw a normal cos one, but that's now 8 pi. To get it, halfway is 4 pi. A quarter of the way is 2 pi. So you just do that bit. So then you can draw your real one like that. Amplitude 4. You may need, alright, so that's the other one. So get the idea, draw the full one, even if you draw it on the side. Cross it out, then draw the bit you need. Otherwise, you try and do it the other way. Oh, you'll be there forever. Alright? Anything else? Do you get, so you still need to watch other videos. I did send 3, that was small angles. Do it on the weekend, alright? I really need to differentiate and integrate. I'm not going to, I need to go on to another video.